Hey there, we're going to do a little preparation for our analytical geometry chapter. So one of the things you need to become comfortable with is what roots are and what they represent. So from a picture, you know that if this is a square, let's say it's a square, I'll mark that the sides are the same length so you know it's a square. If this is a square, and in this square there are 9 rows and 9 columns, I don't know if I'm drawing 9, but you get the idea. Then when I count up all the little squares in here, there will be 81 squares, because 9 by 9 is, well, it's written right here, 9 by 9 is 81. Okay, so this is the picture, and these are the words. What this means, this sign is just a really flattened out R for radical, or root. And what it means is that I'm going to point to this math as I say it in English. If you have a square that has 81 little squares inside, that means that the length of the big square is 9 by 9. That's what it means. That's it. And that's why you can't have the root of a negative number, because there is no such thing as negative 81, because there's no negative number of squares. And there also can't be a negative here if you're just taking the root of number, because you can't have negative 9 as the length of a side of a square. You know that it's a positive number. Even 0 can't be the length of a square. There is no such thing as a square that's 0 by 0. There's no square there. So I know you know what I'm saying, but I want you to just understand the translation from math to English, which is, this means that there's a square that's 9 by 9, and all the little squares inside the big one, the big square, add up to 81. So no matter what the length of the square is, right? Square means length and width are the same. So whatever the side length of the square is, when you multiply that number by itself, this will be the number of little squares inside. I know we start getting to point decimals, which is, how can you have part of a square? Well, you just shade part of a square. But anyway, aside from that, that's what this means. So if that's the case, then you know that 49 little squares must be 7 by 7. And that's what this is. 7 times 7 is 49. Now, another way of looking at this is not even really thinking about the picture and just saying, what number times itself gives you this? Okay, well, what number times itself gives you this? If you need to use a calculator when it comes to decimal places, then do so. And what number times itself is equal to this? And you can just do it. Something times itself. Something times itself. So I'm going to let you do that right now with your calculator. Okay. Now, let's say you're thinking, well, I don't even know where to start. Well, start pushing in some buttons that make some sense. So let's forget about the decimals. What number times itself is 9? 3. So you know there's going to be a 3 here. But is it 0.3 times 0.3? Or is it 0.03? Like, you got to just play around with it and you'll get a feel for what it could be. Right here, you know 169. Forget about the decimal for a second. Well, let's say you don't know your 13 times tables. Well, you know your 12 times tables, because we all learn in school up to our 12 times tables. So 12 times 12 is 144, and this 169 is bigger than 144. So let's try one bigger than 12 is 13, and if 13 doesn't work, then 14, and so on. Because we know we're multiplying a number times itself. Okay. That's your decimals, little, and root, little review to deal with the next thing.